Now, next topic is fluid static. Fluid static. Fluid statics means study of fluid at rest or and study of fluid in rigid body motion. Rigid body motion. What is the means of sub? This is the container. Fluid at rest. Fluid at rest. Here the velocity of container is 0 and velocity of the molecules of fluid is also 0 because it is at rest. So at x direction velocity is 0, y direction velocity is 0, and z. So u not a function of x, y and z. Understand? For fluid at rest. And the study of fluid in rigid body, suppose this is a container and this is the container which moving velocity v, and the molecule, this is the molecule of the fluids, and this also moves a velocity. So relative velocity of molecules of fluids, velocity of fluid particles or of fluid particles the velocity v into 0. So this is the rigid body motion. Now, so u is the now fluid at rest. Fluid at rest. Fluid at rest. U not a function of x direction, y direction and z direction, also time. So differentiate with velocity gradient in x direction is 0, velocity gradient in y direction is 0, velocity gradient is z direction, and also respect to time is 0. So shear stress at x direction means u into du into dx. This one is 0. Shear stress y direction is 0, z direction is 0. So there is no, you can say there is no shear stress acting on the fluid. So there is no shear force acting on the fluids. So you can say when fluid at rest, there 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 is only normal stress, normal there is only normal stress acting on the fluid, acting on the fluid. This is the fluids, this is the container, and there is a and the only normal stress acting on the fluids. So normal stress equal to normal stress, this normal stress equal to pressure acting on the fluid, pressure acting on the fluid, pressure acting on the fluid. Understand what is pressure? What is pressure? Maximum student say force per unit area. This one is not correct. Normal component of force. This is the exact definition of the pressure. Normal component of force per unit area is called pressure. Suppose this is the any surface, this is the force F is acting, as this is theta with horizontal, this is the suppose force. Maximum student say suppose this is the area, force you cannot say force by area at this position. Now resolve the F into vertical direction and the horizontal F. This one is F cos theta, this one is F sin theta. Now you can say pressure equal to force, normal component of force by area. This one is correct, not F by area. Now you can every student understand area is the scalar rashi, is not correct. Area, suppose a small area, suppose a square, consider a square, his side is A. Now this A, X direction, Y direction, I cap, this is the Z, this is the J cap. Now consider this area equal to now cross product cos product area into AI into B j cap. So A B A, this one is A, so A square I into J, I cos J equal to cos theta. This theta is I and J perpendicular to each other, so A square equal to cos 90 degree. Cos 90 degree value is 1, so A square. For scalar product, now scalar product, for scalar product of area A into I cap into A into J cap, area square I into sin theta, vector quantities, sorry, this cos product is sin theta and this one is sin 90 degree, so A square, and dot, when dot comes cos theta and angle is between them 90 degree, cos 90 degree, where sin 90 degree value is 1 and cos 90 degree value is 0. So you can say these points very important. Small area treated as a scalar quantity, vector quantity, vector quantity, understand? Now pressure, note down, pressure is a scalar quantity. Now unit of pressure, units of pressure, unit of pressures, unit of pressure. First of all, SI unit, force by area, Newton per meter square or Pascal. CGS unit, dyne per meter square, and non SI unit is 1 bar. This one is non SI unit, 1 bar 10 to the power Pascal, other 10 to the power square 100 kilopascal, and Pascal divided by 1000, and another is 1 torr, unit is 1 torr. 1 torr equal to 1 millimeter of mercury. So we know 1 atmospheric pressure, 1 atmospheric pressure equal to millimeter of Hg. So 1 millimeter of Hg equal to into atmospheric pressure. Atmospheric pressure. 1 atmospheric pressure equal to into 11325 Pascal. So this value is 13328 Pascal. So 1 meter of Hg equal to so you 1 torr equal to 133.28 Pascal. And another non-SI unit is 1 psi equal to 6894.76 Pascal. This PSI units you can say when you go to the for pump of the bike tire, that time the worker using a measuring device, pressure measuring device. This device is in PSI units. You observe, and 1 psi means 6894.76 Pascal, and this is the PSI unit. Now absolute pressure. It is the pressure measure above the pressure measure above the measure above the absolute zero pressure. Now what is gauge pressure? What is gauge pressure? It is the pressure measure above the atmospheric pressure. Now first, this is the absolute zero pressure line. This is the absolute zero pressure line. This is the atmospheric pressure line. Zero pressure line, atmospheric zero pressure line. Suppose here point A. Suppose there is a point A. From absolute zero pressure, this distance is absolute zero pressure, absolute pressure. But when measured from atmospheric pressure line, this is the gauge pressure. This one is gauge pressure. Understand? From here, this is the gauge pressure. And what is the vacuum pressure? Vacuum pressure. What is the vacuum pressure? What is the vacuum pressure? When the pressure of any pressure of liquid is less than pressure of liquid. Pressure of liquid is less than this is the atmospheric pressure line. This is the absolute pressure line. Less than atmospheric pressure. Suppose another, here is a B points, and at this point this one is vacuum pressure. At vacuum, this is the vacuum pressure. So you can say P absolutes at A equal to P gauge at A plus P atmospheric and P vacuum